Before I talk about electricity, I'm going to talk about problem solving in a strategy context. What you see here is a bunch of outcomes, and one of the fellow text masters really actually inspired me to talk about this since he loves uncertainty. We have a bunch of decision points here that you see in your screen, and each of them leads to an outcome with a certain probability. Some of them might need to be evaluated, and they lead to another outcome. We have different states. When you're looking at a problem, you need to evaluate the current situation, and that presents you with many states, and each of those states might have different characteristics. Some of them are very simplistic, and I'm being very simplistic in my description of the problem. The time doesn't allow us to go into detail. Once you're solving a problem, you need to scan your external environment, as Paul indicated here. You need to look at all your internal environment and scan it. And from that, you're going to derive what kind of resources you need. That includes money, people, and various tools that you're going to use to solve the problem. But you have to be aware that there are interactions constantly between elements when you're trying to deal with a problem. From there, you move into sensing your world. You're going to take measurements. You're going to perform scenario analysis. Paul gave us a few scenarios here, but he didn't go into details. And I hope that we'll see more details in the future. You look at all the different events and the probabilities of such events. When you're dealing with natural world, you're going to have the frequency of events, the duration, the stage, intensity, and etc. Many elements that control your natural world or have an impact on it. You also have expected behaviors, things that you know. You perform statistical analysis on them. You gather data. You analyze it. You perform event analysis, and if you are a little bit curious or advanced, you'll do a lot of probabilistic probability analysis. From that, you're going to have a characterization of the problem. So for each of the events, you're going to have an expectation. This is the expectation that I'm going to get this element or this thing happening at this time, etc. You'll derive models of reality, and of course, models of irreality. You're going to have probability of occurrence, and the big S indicated here is that if you don't forget, you're going to say occurrences because things repeat themselves. History repeats itself. You perform your accuracy, you look for errors, confidence intervals, and I have this certainty that this event is going to happen. And finally, you're going to arrive to solutions. For problem X, I might have solution Y. Or for problems A, B, C, D, I'm going to have multiple solutions. But you're going to ask yourself, is the solution that I have unique? Because the uniqueness of a solution is a problem in itself. Because the cost is going to be static. You want that cost to be dynamic. You want to be able to influence it. And the same goes for the risks as well. Well, you move on to the next phase. I'm going to apply my solution. I'm going to deploy my project or whatever you're doing, you are trying to solve. I'm going to try it, and then I'm going to have these expectations for it. The impact of your solution on the problem will depend on time and a lot of events that you may know that will give you different outcomes. At the end, you're going to end up having a map of outcomes and risks. And this is this diagram here. On the left-hand side, we have a set of problems for which we have known solutions and unknown solutions. For the solutions itself, it's either known or unknown. So if your solution is known for a problem, everything's fine. If the solution is unknown, but the problem is known, you're still in a very good position because you're going to use your brains, your resources, as I indicated earlier, to try and find the solution for that problem. If the problem is unknown, but you have a solution to fix it, it's time to take an action and fire the bastards. Because they have screwed up. When you're in deep trouble, and you will be, it's when the problem is unknown and the solution is unknown. Because that will lead to significant costs, costing human life. If you're working in aerospace, we remember the Apollo, right? There was a solution. And the problem was known. But in this case here, the deep trouble, that's the wet, you're in trouble because you have what is called the Unk-Unk. In military speak, that's a military speak word in aerospace. You try an airplane, you work on it, you come with the solutions, but you spend a lot of time on the Unk-Unk Quadrant. Thank you.